So we talked a little bit about this yesterday, which is your function notation, right? So we talked about, I gave you guys an example very similar to this with like the y equals, 4x minus 1. And all we did was we just changed it to function notation. And I said, well, that's f of x is equal to 4x minus 1. So all I did is I just replaced my y by f of x. And the reason why I did that is because it's a function. Remember, we did the straight line and then the little kind of curve and then the sad face, right? Like, so what makes a function? If I can draw a vertical line throughout the graph and it only touches the graph at one point, then it's a function. If anywhere along the graph it touches more than one point, then it's not a function, okay? So we read this as f of x equals and in this case, it would have been 4x minus 1, right? So that's how you read it. It's f of x. F of x is the output, and x is the input. So remember, we're talking, right? We're not, like f of x is a unit. The parentheses does not mean multiplication, right? It's a unit. They're like stuck together. They're not to be separated. Okay, so you have to look at parentheses in context of the problem. Sometimes it means parentheses, other times it does not. Okay, so if I wanted to find f of negative 7, my negative 7 is like where my x is. So I'm going to plug in my negative 7 in for x, where I have 4x minus 1. So f of negative 7 is equal to 4 times negative 7 minus 1. So f of negative 7 is negative 28 minus 1. So f of negative 7 is negative 29. And I leave it. I'm not dividing by negative 7. Because I'm solving for what happens when I plug in negative 7 in for x. What do I get as my output? Okay. Questions that you guys have? And we did, like I made up an example like this yesterday, so it's pretty straightforward. There's graphing ones like we did yesterday too, where you have to look at the graph and figure out what the y value is. It'll be the same exact thing. The reason why the sections are repeated is this is very, very important. This idea of function notation and understanding how it works is super important. And we're spending a lot of time on this because when Mrs. Roach is doing advanced math right now, she said that is the one thing that people are getting very confused about is this notation. Okay. All right. Let's do 8. And I'm doing 8 because it's an absolute value, right? So I just want you guys to know. It doesn't change anything. My negative 7 is like where my x is. So if I want g of negative 7, I plug in negative 7 in for all of my x's in my equation. All of them, not just one of them, not just the one I feel like, but all of them. So I get absolute value of negative 7 minus 49. Because I take that negative 7, I square it, I get a positive 49, but there's a subtraction sign in front. So g of negative 7 is absolute value of negative 56. So g of negative 7 is a positive 56 because of the absolute value. Questions that you guys have? So let's get a little trickier. Let's look at 10. Maybe we should look at 9 first. I lied. Let's look at 9 first. I'm going to do 9 and 10.
How dare you?
I know.
I heard the teacher of this class do something teacher-like.
All right. So I want f of c plus 7. So my c plus 7 is the entire thing is like where my x is. Okay. So f of c plus 7 is 4 times c plus 7 plus 11. So notice, I took that entire c plus 7 that was in that parentheses and I plugged it in for x. Now it requires, unfortunately, more effort in order for me to solve because I'm going to have to distribute my 4 to both terms. So I still have my f of c plus 7. And now I have 4c plus 28. And then that little plus 11 at the end just kind of tags along for fun until I can combine my like terms on the right-hand side. Questions that you guys have? We are going to add 11. I just want to make sure that nobody has any questions yet. So f of c plus 7 is 4c and then plus 39. And again, I'm leaving it. I'm not dividing by a c plus 7. Because I want to know what happens when I take c plus 7 and I plug it in for x. Reason why I said I didn't want to do 10 first is because it has a lot of negatives involved. Sometimes negatives require more effort. Addition is a lot easier for most people than subtraction. So I'm going to take this 2k minus 5, and I'm plugging that entire thing in for x. So I have a negative 9 minus 2k minus 5. And that's what I'm saying. It's like it's weird because of that subtraction. This subtraction sign goes to both terms. So h of 2k minus 5 is equal to negative 9 minus a 2k and a plus 5. And then I combine my negative 9 with my positive 5, so I get a negative 4 minus 2k. And you could write it as negative 2k minus 4. Same thing, doesn't matter. Questions that you guys have? So now I can take like a function, evaluate it, and do something else with the equation, right? So I can add something to it. I can multiply something by it. I can evaluate the two functions and do something with them. And so like if I wanted f of 4 plus 9, I have to find what f of 4 is first. So here with 11, I'm going to take my f of x equation that's to the left, and I want to find f of 4. 4 is like where my x is, so I'm going to plug it in. 8 minus 3 times 4. So I get f of 4 is equal to 8 minus 12. So f of 4 is 4. Negative 4, sorry. Now this is where it gets a little weird because I want an f of 4 plus 9. So f of 4 plus 9 is negative 4 from before. and then I'm adding my 9. So I get 5. So now you're not just evaluating the function, you're doing something else with it. Questions that you guys have? Yes, Trejo.
How did you skip from f of 4 equals -4 to f of 4 plus 9?
Good question. So what I started off with is I chunked my problem into two things. So I first found just what f of 4 was first. And then what I did is I went back to find the whole thing, which was my f of 4 plus 9, to get my final answer. Yes, Mason?
So your final answer would be f of 4 plus 9 is equal to 5?
Yes. Which makes it weird because you want to subtract that 9, and that's not true. Because I'm not solving for f of 4, I'm solving for f of 4 plus 9, which is different. And I could skip steps for all my people that want to skip steps. I can. I could have written it as f of 4 plus 9 and then found my f of 4 within there and then added the 9 afterwards and had it in one big long string, right? But in a lot of ways, I like to chunk things a little bit so it's a little bit easier to manage, okay? Questions that you guys have? So again, I would chunk this, and I'm going to use the stuff, I'm going to use the spot where 13 is. But I'm going to chunk this, and I'm going to first find what h of 2 is. Right, so way over here, I'm just going to use the slot where 13 is. I'm going to find h of 2. So it's negative 5 halves times 2 minus 1. So now my fractions, my 2's cancel out. So I'm left with h of 2 is equal to negative 5 minus 1. So h of 2 is equal to negative 6. That's my first little piece. My other piece with my function notation, right, is the fact that I have to find f of negative 9. So over here off to the side, I'm going to find f of negative 9. I use my f equation, not my h equation, but my f equation. And I have 8 minus 3 times a negative 9. So f of negative 9 is 8 plus 27. So f of negative 9 is equal to 35. Now I got all my little function pieces together. So back to what Trejo was asking is how do I jump these steps? So now I want to go back and find out the whole string, that whole equation, what that whole equation is equal to. So I know I'm going back to the beginning, and all I'm going to do is plug everything in. So I have my 3. And then I'm multiplying by h of 2, which is negative 6. And then I am subtracting off my 35. So this whole big string of things. So my 3 times h of 2 minus f of negative 9 is equal to negative 18 minus 35. which is negative 53. So I'm not, solving for any of those functions. I'm solving for that whole equation, which is what makes it a little different. Questions that you guys have? So again, I want to make sure that I give you guys plenty of time to work. So problems like this is what we did yesterday, right? But we did it with the graph. So I just want to make sure that you guys understand how to do this before I hand you guys your assignment and cut you guys loose, okay? But what did we do yesterday? If I said h of x was equal to 39, what did I look at on my graph? X values or y values? I looked at 39 being the value of y and what the value of x was on the graph. Okay, so that's what we did yesterday. If I said h of x is equal to 39, I'd look at, okay, where's 39 along my y-axis? Let me go find it along the graph and then know what that x value is. That's how we found it. So I'm going to use that same mentality when I do this and I have an equation, right? Oh, why would I choose that one? But that's okay. I was like, fractions. So I'm going to put 39. I must not like myself very much. Is equal to negative 5/2 x minus 1. I'm like, why would I do this to myself? Actually, it might be good because if you have a fraction in your homework, then, at least you know what to do. So I want to solve for x in this case, right? So I'm adding 1 to both sides, right? Remember, we draw our line through our equals. Add 1 to both sides, so I get 40 is equal to negative 5/2 x. And then remember, we multiply by the reciprocal, which is negative 2/5. So I get negative 80/5 is equal to x. And so you have to check to see whether or not it divides in evenly, which it does. It is negative 16. But you can do the little, I guess you could use your calculator too. For me, a calculator requires more effort. Because I have to go find the calculator, or I have to go open up my phone and then find the app. And then ultimately, if I use my phone calculator, it takes me forever because I type in the wrong numbers. And then I'm annoyed. And I could have just done long division faster. Unless you've got Alexa at home, and then just ask Alexa. But the new update for Alexa has been making it slower. It's been annoying me. Okay. Questions that you guys have? The other ones are just like what we did yesterday, right? We look at the graph and we figure it out. But you guys have any questions?